Welcome, everyone. My name is Jason Schleifer. I am an animator and a creative director at AWS. Today, we also have Rick Grandy, who's a senior solutions architect from Nvidia. I just ran, so I'm a little out of breath, sorry. We're going to be talking about what it's like to actually create animated content in the cloud using AWS services. It's something we're really excited about. We're seeing a lot of customers, a lot of studios start making their transition to working in the cloud, and we want to talk about what that experience is like. So, when we talk about studio in the cloud, what we're really talking about are a number of different sort of pillars that we're seeing studios go through as they kind of make that transition from being all on-prem to being in the cloud. The first one is rendering. So, rendering is a really nice, easy sort of transition for studios. So if they're used to creating content on their own, they've got their own little data center and everything's great, and then they start thinking, you know what, we've got too much work, we need to start bursting to the cloud. Rendering is a really nice sort of contained workflow that allows them to move forward or move up. We also are going to be talking about software, what tools people need as they're moving to the cloud. We're going to talk about virtual workstations. This is the part that I love the most because I'm an animator. I like to be able to animate. I like to draw. The fact that we can actually have workstations now streaming in the cloud is super exciting. And Rick is going to be talking a lot about some of the stuff that Nvidia is doing to make that possible. And then we're also going to be talking about AWS infrastructure, how we actually make this possible to be global and stuff like that. So before I get started, when I say studio in the cloud, when I talk about animation studios, what we're really talking about here are people who are doing animation and visual effects for TV, for film, for commercials and stuff like that. A lot of what we talk about is totally applicable in other areas and other industries, but focusing on this is sort of like, it's my wheelhouse, it's the stuff I love. So during the talk today, that's really what we're going to be focusing on. So let's go ahead and get started with rendering. So about 3 years ago, AWS acquired a company called ThinkBox, which creates a tool called Deadline that allows studios to manage their on-prem and cloud-based infrastructure. It's really great for being able to control like where renders are happening and what's going on. So we'll talk about how we're actually using rendering. For those of you who aren't into animation and don't understand the animation pipeline yet, this is a really simple space where we can define how rendering works. But basically, it's sort of the end of the pipeline. It's sort of like when you're sitting there and saying, okay, we're going to do some amazing animation. We're going to have some models. We're going to apply textures. We're going to do lighting. We're going to do all sorts of stuff. And then at the very end of the presentation, at the very end of the shot, you basically hit a button and you say, okay, go ahead and tell me what color each of these pixels are. That's the rendering side of things. And it's really nice to be able to send that off to a machine and say, I'm working on my shot, and I'm going to send this somewhere else. It's going to render, and I can keep working while the computer is doing its rendering. The way studios usually handle this is they'll create a small little render farm. This is like early on. They'll say like, okay, we're going to do 100 machines that we're going to render on. So they create a capacity, and they say, okay, artists are going to be working, we have 100 machines, and then artists will say, cool, I want to render, and they send some jobs to that farm, and as long as the jobs are less than what that capacity has, everything's great. If a job takes 8 minutes, and they have enough capacity, they get the images back in under 8 minutes, or around 8 minutes. If they have a job that takes an hour, great, they'll get it back in an hour. As long as they stay under that capacity, everything's wonderful. The problem runs into when you've got jobs that go over that capacity. So imagine, artists are like, this is amazing, I can get my stuff back really fast, this is awesome, I'm going to send all my work over there. You should do it too, and all your friends are like, yeah, me too, wah! And they throw all these jobs on. All of a sudden, you run into this problem where there's not enough capacity to handle those jobs. So what happens is an 8-minute job could sit there and wait for an hour, 2 hours, 3 hours, until there's finally enough capacity to take that job. So you end up with things like sort of stacking on top of each other, like that, which happens on and off throughout a production. And if you scale out, what studios will try and do is say, okay, we're running into this situation where we just don't have enough capacity for all the work that we're trying to do. So the way around it is to buy more capacity. So they increase that, they spend some money, and then more jobs go on, and that's great for a while. You spread that over the course of a show, and what you end up with are these situations where you've got too much capacity for the work on, which is just wasted resources. These are machines that you've paid for that are just sitting there not doing anything. But you also have high utilization, which is a potential bottleneck. So if you're trying to turn something around for a director for dailies the next day, and the job is sitting on the farm waiting, that's a real problem. And you end up with artists sitting there going like, I would love to show this. I'd like to get my shot finaled, but I can't because it's just sitting there waiting. And they end up drawing pictures and doodling and doing caricatures and all the stuff that we like to do that doesn't really add anything to the show. So what studios want to do is basically, and actually before we go on to what they're doing to solve it, what we usually see on a show is instead of things sort of happening throughout the course of the show where you're like rendering and then not, and rendering and not, what usually happens is everything waits to the end of the show, and then you get this massive bottleneck at the very end where everybody's trying to get shots through, which is a real pain. And what you don't want to do is then like create all this capacity to cover those crazy peaks, because then you're spending all this money on massive amounts of capacity that you're hardly ever using. So that's a problem. There's this amazing opportunity that's happening right now in animation and visual effects where there are a ton of companies that are looking for animated content. So you've got lots of streaming services, you've got some really amazing movies with tons of visual effects and animation. TV shows are becoming way, way more full of effect. So there's a lot of opportunity, and studios are seeing this opportunity, but they're also seeing this problem they have with this on-prem infrastructure. So they're sort of having to try and figure out how to solve this problem. Without going to the cloud, one of the things they can do is buy more hardware, but that means they have to spend all this money up front in order to be able to handle all of the stuff coming in, all their capacity. They could sacrifice quality, which as an artist is like, no, you do not want to do that. You don't want to do your worst work. Like, you're always trying to get better. Or they can turn down work. And a lot of studios have done this, where they're like, we're working on a show, there's a new opportunity that comes in, but there's just no way we're going to be able to render it because we don't have enough capacity to get the job done. So these are things that studios have been having to deal with. And what they're doing right now, which we're super excited about, actually, this makes them very sad, obviously. But what they're doing now, which we're excited about, is that they're moving to the cloud. And they're saying, there's some opportunity here to go to the cloud. And AWS is obviously very excited about it. That's why you're all here, because we're talking about doing stuff in the cloud. So when we started working with companies to think about moving these tasks to the cloud, what we thought was going to happen was that studios would say, all right, cool, I'm going to go to the cloud, so I'm going to simplify my on-prem infrastructure. Instead of having all these computers on-prem that I'm managing, I'm just going to have a small amount, maybe 50 machines, maybe 100 machines, and just sort of cap out on that. And then we thought they were going to take all these jobs that were sort of going over their capacity and just like, boop, pop those up to the cloud, and everything would be great. We thought that was what people would do. It turns out that's not what happened. Instead, what they did was they realized they now had all of this capacity because they made it super easy to be able to go to the cloud. And instead of waiting till the end of a show to do a render, they would just be rendering all the time. And the cool thing about this is that they actually were taking their existing capacity that they had on-prem and extending it to 2 to 10 times their current capacity. And that's just like always there when they need it. They're not paying for it when they're not using it, but if they need it at any moment, they can just crank up, which is super awesome because it means that time for them becomes elastic. When a customer says, I have this shot that I need it done by Friday, they're not going, okay, can we render the shot and get it done by Friday? What they're saying is, yeah, we can get it done tomorrow. When do we want it? We want it now? Okay. I was working at a company before AWS where we had a delivery on a day, like we were delivering that day, we were getting notes from the director. We were able to turn around rendering and compositing notes that same day because we were able to get those notes, make changes, throw it to the farm, and come back and get our stuff back, which is awesome because it means that as a client, as a creative, you're saying yes to the director, yes to the producer. You're not saying no. You want to be able to say yes and partner with them. So we're seeing a lot of customers doing this, which is something we're super excited about. I'm going to talk about a couple of them right now. Milk Visual Effects worked on a show called The Good Omens. Have you guys, anyone seen that? Yes? Excellent. They had this really awesome challenge where they had 5 months to deliver 650 shots with a bunch of different work. So it was like characters, environments, effects. All of this is really complicated. They needed a really good rendering solution in order to be able to handle this. So they used ThinkBox Deadline, which is our render manager, and EC2 Spot to manage all their instances in the cloud. And they were able to basically manage with one tool, manage both on-prem and cloud instances. They peaked at 83,000 cores, which is a lot. Way more than you could have like in a room in the back. And they averaged about 15,000 cores a day. And they used Deadline with their custom pipeline. So it was super awesome for them to be able to deliver this. The great thing about it is that they were a small team, and they were able to scale and actually create work that normally would have had to have been created by a much larger team. So we're super excited about what they were able to do. Another company called Fuse Effects. How many of you seen Orville? Yes, I love the show. It's fantastic. So they had this epic space battle that they needed to do, which was about 8 minutes of footage. They wanted it to rival what you would see in Star Wars. So they wanted this like massive space battle for 8 minutes, 228 shots, and they had 8 weeks to do it. So 1,000 person hours to get this thing done. Again, they were able to use Deadline. an EC2 spot, again, only paying for the instances that they were using when they were using them. They have an in-house production tool called Nucleus, and they were able to integrate with that. So Deadline is super flexible. It allows you to integrate with whatever pipeline you have. And as you can see here, like a massive amount of rendering that they were able to get done. So this is an example of what a sort of hybrid architecture would be like. So when we say hybrid architecture, if you talk to anyone about this, what we're saying is like, we know studios have an existing on-premise infrastructure that they've already invested in. People don't want to throw that away. You spent lots and lots of money building this up. So a lot of studios, what they're doing is they're saying, okay, we're going to use that on-prem, and then we're going to burst to the cloud. And this is an example of what that might look like in order to get that done. We do have a lot of documentation, which I'm going to show you later, about how to spin this up yourself if this is something you're interested in doing. One other company I wanted to highlight real quick is Rocket Science VFX. So they were working on The Expanse. Show of hands for anyone who's seen The Expanse. Awesome. I like that we have lots of people who watch TV. I don't feel so bad about myself. It's awesome. So they had this really interesting challenge where they had an infrastructure they were using before, but they decided to use Redshift for rendering. So this is a GPU-based renderer. So what they wanted to be able to do was actually expand their infrastructure, use NVIDIA-based GPU instances to be able to render, but then also on older projects be able to use a CPU-based render farm. So with Deadline, again, they were able to actually manage both with one interface. So the render wranglers could handle whatever type of pipeline it was that they needed in order to get this done. Super flexible, and they were able to iterate quickly and refine all their shots as they needed. So that's sort of rendering when you're talking about going to the cloud. That's how we manage rendering. The software is a major part of that, which software tools you use. There's not a single studio out there that uses one tool to do everything. They use a little bit of this, a little bit of that, depending on which artists are comfortable with. Ideally, you can go into a situation where an artist is like, I'm super comfortable with this tool, I want to use that. Another artist is like, I'm super comfortable with this, I want to use that. Depending on the show, you're going to switch around. So the nice thing is that we have this ThinkBox marketplace, which has pretty much most of the tools that an artist would want to use available. And what we're doing with these is we have something called usage-based licensing. So just like with your compute, where you're saying, I'm going to spin up an instance, I'm going to pay for it while I'm using it, and then I'm going to spin it down and not pay for it, we have the same thing with licensing. So when you're ready to render, you can say, it's the end of the show, we need 6,000 licenses of V-Ray. So I'm going to go ahead and render with those, and then I'm going to spin it down, and I'm not going to pay for them. That being said, we also do have the ability to have bring your own license. So some studios have already purchased licenses. You can use those as well. And you can sort of mix and match depending on whatever it is that you need to do. We're really trying to make sure that the tools that you want to use are the ones that you have available to you, and you're paying for them when you need to use them. The thing that we're also really, really excited about is that open source tools are becoming very, very popular in the visual effects and animation industry. So this year we joined the Academy Software Foundation. And if you guys are unaware of this, it's a group that basically is supported by the Academy of Motion Pictures of Arts and Sciences. If you don't know who they are, they're the ones who do the Oscars. Hopefully, everyone know the Oscars? Yes, awesome. So they do that, and what they've seen is that basically there are all these, like 84% of the tools, or 84% of the industry uses open source software, and so their whole mission is to make it easier for people to get together and use these tools interchangeably. It used to be really tough where you'd have a show, two different studios working on a show, and you're trying to send data back and forth between the studios because they're both working on it, and that was a real challenge. File formats weren't matching, color space was off. So this group is really trying to make sure that this is consistent so that everyone can be using the same tools and moving forward. And as you can see, there's a lot of companies that are involved. We're super excited to be in this ecosystem. And keep watching the space to see what we're doing over the next year with this. We think there's going to be a lot of great opportunity here. So the virtualized workstations, this is the part that I get super excited about as an artist. We've talked about rendering. You're going to send stuff to the farm to do that job. We've talked about the software that's needed. But most of the work that's done day to day at a studio is an artist sitting at the computer, animating, lighting, compositing, doing visual effects and things like that. So being able to virtualize a workstation so that an artist doesn't have to, or studio doesn't have to buy a big machine sitting under somebody's desk keeping their feet warm, is awesome. So when we talk about why you would want to do a virtualized workstation, the big thing right off the bat is it reduces your overhead. If you don't have to sit there and refresh new exciting machines every 18 months as new machines come out, this is a huge benefit. You can buy a thin client, you can get like a super simple machine, and artists can just log in to whichever instances they need to do their work. We've had artists at studios where you'll be working on a visual effects shot, for example, and you've got like a massive simulation that you need to run. So you're using all of the resources that are available on that machine running in the cloud, then they want to start setting up a second shot, they can just spin up another machine exactly the same, looks the same, it's spec'd exactly the same, and then just start setting up another shot on that machine. So they could be working with 2 machines for much less money than it would cost for you to buy multiple machines for that particular artist. So a huge amount of reducing overhead. Also allows people to work at home, potentially, and still log in and see the exact same infrastructure, exact same setup as what they would have if they were working at the studio. Another big thing that we're seeing is talent is global. So it used to be that you would go to particular regions where you would have a lot of artists who could create this type of work. It's very, very, takes a lot of skill to be able to create visual effects work and to create animation. So people had to be in particular regions to be able to do the work, but people all around the world are extremely talented. And so by virtualizing your infrastructure, virtualizing the machines, you can actually bring people to work on your jobs without having to physically move them around. So it's a big goal of ours is to make sure that you don't have to have these nomads of visual effects artists who are moving from one location to another location to another location just to be able to work on stuff that they're passionate about. A big win for the artist is like, I can go and work on a show that I love, that I'm just so passionate about, and I could bring my best self to it without having to move my entire family and disrupt my life. The thing that this allows for, which is very exciting for studios, is thinking about bursting the workforce, not just the compute. So like with rendering, they're used to bursting the compute whenever they want and then shutting that down, paying for it only when they use it. If you're thinking about bursting your workforce, every show has a different sort of ebb and flow for what artists you need at any given time. Early on in a show, you're going to be using modeling, surfacing, all the setup, pre-visualization, and stuff like that. Towards the end of the show, you're using animation, compositing, effects, rendering. Those are different artists with different skill sets. And the ability to be able to hire up and hire down very quickly as you need to, as what's appropriate for the show, is a huge value. And of course, security is super important. There are studios that exist that when they would hire an artist, say in Spain, to do some work for a character rig, they would literally send a model to Spain for the character rigger to work with, who would then send a model back over email, which is definitely not secure, highly not recommended. So by being able to virtualize the workstation, you could just send pixels, which is much more secure. You can control exactly who has access to these machines, which is amazing. So when we went and talked to customers and we said, if we're going to be virtualizing workstations, what do you actually need? Like, what would your artist want that would make it seem like they were working locally with their stuff on-prem, but it's all running in the cloud? What kind of options do you want to be able to have? And they all said they have to be super high spec. We want to be able to have both Linux and Windows available. Some workflows really require Windows. If you're using like Adobe products, for example, you want to be able to have Windows instances. Other studios really love Linux, and they built their entire infrastructure around Linux with all their plugins and pipeline and everything, all Linux-based. So we wanted to be able to have both. You want to be able to stream dual HD or 2K monitors with color pixel accuracy. Video, audio need to be in sync. You don't want to be having animators animating everything that's like 3 frames off. It's just going to look really bad. So everything has to be able to sync. And you also absolutely have to have Wacom and Cintiq support so that when you're doing drawing, you've got pressure sensitivity and the latency is super, super low. So we're really excited about these new G4 instances that Rick is going to be talking in more detail about. But the great thing is they're really right-sized for these tasks for people creating animated content. These are the quick starts that I talked about earlier in terms of being able to, like, if you're interested in trying these things out, building up your own cloud infrastructure, you can follow these. They're available on the website. And we're working on some other tutorials that we'll be releasing soon as well that really tell you, like, how to get this stuff up and going in a way that's not super complicated. So we've talked about rendering. We've talked about software. We've talked about the virtual workstations. So the infrastructure, which is just all AWS, is amazing. As you guys know, we have 22 geographical regions. We're everywhere. We're global. We've got data centers that are super reliable. And then if you watched the keynote on Tuesday, we announced the availability of our first local zone. And so this is really exciting because there's definitely places where there are not regions available for people to work, like LA, for example. We have a lot of artists in LA who want to work, but connecting to Oregon is not a great experience for when you're trying to virtualize a workstation. So now with local zones, we can actually have basically, you just launch a subnet that's in LA, and you have all the same infrastructure that you need connected to all of your data that's already existing in Oregon, but when you launch a virtual machine, it's running out of the LA local zone, which is really exciting. So I know as an artist, I have an animator on my team who's in LA, and I'm super excited about this because it means she's going to be able to actually work at the same rate that I would have working out of San Francisco or working out of Oregon. So we're super excited about these. And in fact, if you go over to the show floor and go to the global infrastructure booth, we have a couple of artists there who are actually showing what it's like to set this up. And you can try playing for yourself with a Wacom tablet and see how it feels to actually use it. It's amazing. So we're super, super thrilled there. One of the other things that we talk a lot about is actually managing your data when you've got your machines up. So we like to use FSX for Windows. It allows us to have a Windows file server. So when I bring up an instance in one area and I bring up an instance in another, all of my artists can access the same data. It's really easy to get set up and going. It's a managed service that AWS provides. We also have one for Lustre for really compute-intensive workloads. So this one works for Linux, but of course we're also all about customizability and choice. So for example, you can either use any of our other partners for like Cumulo or Weka.io. Both do really great high-performance cloud file systems. And then also if you're using Deadline, you've got your on-prem infrastructure and you want to use that to maybe burst just rendering to the cloud, you can use S3 synchronization and EBS on all the instances that you bring up. So there's a lot of different options here. If this is something that you're interested in exploring, come up and talk to me after the show, and we can get you talking to some of our business development people, some of our SAs, and they can help you figure out what the right solution is for you. So I did want to go through a quick example of some of the Studio in the Cloud architecture that we've set up internally that's worked really well for us while we're creating content. And I'm going to actually step through it and kind of the process we did. So imagine you've got your admin who's in an on-premise studio, and then they're going to say, all right, I'm going to create a studio in the cloud. So they choose a region, create a VPC, and a couple of availability zones. Then they add a couple of subnets, maybe one regular one of the local zones that's in LA. And then because they're going ahead and setting this up, they want to actually be able to have an IAM profile for each of the artists as they're logging in. Maybe they're using Active Directory, so artists can keep track of all their preferences as they're using different tools. So use directory service for that. Start using Route 53 to manage all of your networking. Go ahead and use CloudWatch to make sure that you're tracking everything that's going on. And then you connect through remote desktop, for example. Start setting up your file system. So again, use Weka or Cumulo or FSX, whichever you'd like. Set up S3 for stuff that you're going to be storing in the back end. And then, of course, use Glacier so that anything you're not using very frequently, you throw that off so it's much cheaper to use. Now that you're spinning up and using resources, of course, you want to track that using the budgeting tools that are available. But your artists are saying, hey, I want to start working. So you go, cool, let's go ahead and create a couple of AMI. So Amazon Machine Images, for those of you who haven't set those up, these are basically how you determine what tools are available to each of your artists on the machines. The nice thing is you can go ahead and say, I'm going to create one that's specific for VFX artists. So it's going to have all the tools that they need to do their VFX work. I'm going to have a different one that's set up for all my editors and a different one that's set up for animators. Or you could create a single one that's available for everybody. So you set up a bunch of those, go ahead and spin up some G4 instances, make sure all the data is encrypted, and then allow the artist to connect through a really wonderful tool like Teradici or DCV or something like that. Teradici is fantastic. A lot of studios use it, so highly recommended. And then, of course, if you have any remote artists, you can have them connect through the same thing, and everyone sees the exact same infrastructure. Once you're ready to start rendering, you go ahead and choose ThinkBox Deadline, spin up a bunch of Spot instances. The way we like to use this is we actually use Windows instances for all of our interactive work, and then Linux instances for all of our rendering. So the nice thing is you can totally interchange those as much as you want. And then, of course, because you've got all this stuff set it up, you want to use the trusted advisor to make sure that you're actually spending money where you should be and not spending it where you shouldn't be. So those are sort of the 4 pillars that we see as the studio in the cloud. Again, rendering to be able to do your render jobs, the software that you need to be able to compute those jobs, virtual workstations so you do the work, and then the infrastructure that allows you to build this wherever you want. So next, what I'd like to do is introduce Rick, who's going to come up and talk about some of the things that NVIDIA is doing to make these workstations amazing. There you go.
Thank you.
Sure.
Is this on? Awesome. Hey everybody, I'm Rick from NVIDIA. I'm a solutions architect. I help studios build custom solutions to integrate either on-prem or in cloud. And we're going to talk about GPU technology specifically for media and entertainment and what we can do with these new G4 instances through Amazon. So content creation is evolving and studios and projects are demanding much greater flexibility, higher capacity, and we're seeing a lot of trends. So in order to remain competitive, firms need to create this high-quality original content, bringing in the best people regardless of location. And pretty much everyone knows that the death of you is kind of some kind of downtime or data disruption, and also if there's a security risk, you don't want to leak your assets out there. So that's where kind of virtualization comes in. And as Jason talked about before, when you've got this virtual studio, a lot of these things go away. And when we look at like what we're bringing now is we're bringing our whole Quadro driver stack and the full performance we get on our workstation machines into a cloud. So right now we're talking about application and desktop solutions that have been around for a long time for virtualization, but they haven't been viable, from a cloud point of view and from virtualization, mainly for quality reasons. We're talking about, animators and artists have a much greater attention to detail. They need the pixel depth. They need greater resolution. They need things that are clear, and that wasn't always available with all the virtualization solutions that were out there. Also, GPU rendering. GPU rendering is now becoming a standard. It's bringing kind of this powerful capacity to these workstations that wasn't available before. So as all of the render solutions are moving from being CPU-based to being GPU-based, we want to be able to harness those solutions also in the cloud. So how does this whole thing work? So we're just kind of showing this kind of little tech dive. We've got like a CPU-only VDI instance. And this traditional instance is powered only by the GPU or by the CPU. And we've got the visualization layer and the hypervisor. It's basically taking everything you're doing, even graphics, and shuttling it down to the CPU level. But the picture on the right basically illustrates the fact that we've got a GPU-enabled server. And with our virtual GPU environment, essentially we've got a manager that's looking at all those graphics calls, all the API calls, and we're actually shuttling those direct to the GPU. So you're going to get much higher performance, much higher throughput. So not everyone has the same requirements. So kind of when we look at like standing up these instances, Amazon has put together these new G4 instances. And there are multiple different types of users. So you might have, animators, producers, effects artists. They might have higher demands. So you can get like, an 8x large or a 12x large, which has, 4 T4 GPUs embedded in it. Or you might have your video editors, and they're not pushing quite the level of data around, so you can scale them to a 2x large. Basically, you can size for the application, and you're not limited. So it's not like you went out and you bought a whole bunch of workstations, and now some people are underpowered and some people are overpowered. And as Jason mentioned earlier, rocket science visual effects, they're kind of a really good candidate for showing how this thing can work really well. As we see in season 4 of The Expanse, they shifted to Redshift, which is a GPU-based renderer. And they were looking at like, okay, well, what can we do on-prem and take advantage of what we have now, and how can we use this new cloud bursting capacity? And between January and July, they kind of did this test. And in January and February, they didn't use any cloud capacity. They were 100% on-prem. But in March, they used about 2.5% of their render capacity was in the cloud. And they were running, through the life of this job, 10,000 jobs, 10,000 render jobs were submitted across all the various different iterations of finals and tests. But by July, over 30% of the rendering was done in the cloud. And I want to go back talking about that. That was using the old G3 instances, and they were using the old M60 GPU architecture, which is a great GPU, but it's a few generations of architecture old. About a month ago, Amazon introduced these new G4 instances, and they used our new Nvidia T4 GPU, which is based on a new Turing architecture. This GPU is about twice as fast as the M60. So just that step up alone, you're going to get twice the speed. But then now, with all of the renderers coming online, taking advantage of this performance, this is a very universal GPU. So this GPU has CUDA cores for your basic shading and processing. It's got tensor cores for doing AI processing, inference and training. We can do 5 gigarrays, and we'll talk about gigarrays and stuff when we jump into ray tracing. But it's got tons of memory. So when you look at like a lot of these workloads, people weren't using GPUs for professional rendering graphics mainly because they were memory limited. Like if you've got 12 gigs of textures and you've only got an 8 gig GPU, good luck. But the big question is, with all this technical information, why should you care about this? Why should you care about the GPU and the instance that you're setting up? And the first thing we talked about was the ability to do virtualization. So now we can actually virtualize the Quadro drivers in the cloud and give you essentially a desktop experience remotely. But what you're also getting with the T4 is RTX ray tracing. So this is kind of the new technology that we've brought out, fixed function silicon in the GPU that greatly accelerates one of the most compute-intensive parts of generating a final image. But then you also take advantage of CUDA XAI. Essentially, we've got these RT cores, or the tensor cores, specifically for accelerating the matrix multiplies that are used for inference. And we'll get into why that's going to be important for the studio of the future. OK, so we're going to move on to ray tracing. Essentially, we've got RTX. And everyone wants to know, well, RTX is great, but what does it mean? And kind of how is it faster than ray tracing without RTX? And can we kind of break this down? And so I kind of do a little walkthrough of like, what is a ray tracer? So to understand the hardware, we need to kind of understand all the components that are going into the rendering. So we've got our 4 main components, and the first one is shading. Essentially, when I look at in any independent pixel, what is the shade of that surface going to be? What is the light doing when it's interacting with that surface? And then we have an acceleration structure. Essentially, we look at the scene, there's a whole bunch of objects, but there's also could be a whole bunch of dead space. So we want to figure out that, we only want to concentrate the rays where there's stuff to concentrate rays and kind of ignore all the dead space. And we've got denoising. Denoising comes into play, whereas, if you're, doing something, academic and you have 6 days to render an image and you can render a ground truth that's, 100% noiseless, great. But in production, you have a deadline. And at a certain point, you can kind of use these denoising algorithms that will go in and be able to clean up an image so it looks like a final image, but you didn't have to spend the time to calculate it. And then there's the actual ray tracing. The ray tracing is literally just like shooting a ray and seeing what it hits. Is there an intersection? And then you can do your compute on it. So in 2010, Nvidia released this API called Optics. And essentially, it was designed to break down the development of all these individual pieces so that over time we can start replacing what's done in a generalized compute fashion into fixed function hardware. So while the CUDA cores are much faster than CPU cores as far as being able to compute, say, shading, if we created a part of the chip that all it did was accelerate ray tracing, that ray intersection, then it would vastly speed up one of the most computationally heavy part of the whole process. And so with optics, that's allowed us to do that. And right now, we have almost every major renderer is switching over to an optics-based system. So while you had Arnold used to be CPU only, now there's a GPU version of Arnold. There's an RTX-enabled version of V-Ray coming out. Redshift, pretty much everyone is moving over to it. So why is ray tracing so hard? We talk about it being so computationally challenging. And why does dedicated hardware help? Essentially, it's because there's a ton of calculations you need to do. It's basically a brute force thing. So we look at all the calculations that we need to do, and if we look at something like this bunny, the bunny is not covering the whole screen, so we still want to optimize so we only shoot rays at the bunny, right? So that's where we come up with this whole thing of a BVH, a bounding volume hierarchy. So this is an acceleration structure that basically says, I know there's 700,000 triangles in the bunny, but if I'm shooting something that goes past the ear, I don't even want to calculate that it hit a triangle, just ignore it and move on. So while BVHs are not a new idea and most renderers use them, over time it takes a lot of detail and a lot of research to optimize them. But it kind of breaks down to this. You can do 1,000 calculations on whether you hit triangles, or you can do 10 tests of whether it hits a bounding box and 10 more tests of hitting a triangle. So 20 tests versus 1,000 tests to get the same result. So that's the kind of optimization we get with this. So if we look at what we do within the streaming, the SMs of our GPUs, a good chunk of that whole big yellow section is essentially just looking for intersections. And last year, at SIGGRAPH, we unveiled our Turing architecture with the Quadro, the RTX 6000, and these are the first GPUs that actually had that silicon, that RTX component that actually will accelerate that. And so when we look at all of these pieces now, where everything used to be covered by the CUDA cores, we now have these dedicated tensor cores for helping out with the denoising, and these RT cores that are helping out with the ray tracing. So what used to happen like this now goes to this. So now the most compute-intensive part of it, which is the shading, we now give much more time on all those thousands of cores that are available to it. And I want to show an example. So we basically stood up a G4 instance, a couple days ago, and this is the watching paint dry video, by the way. So they say only have about 2 minutes on any particular slide. So I've got 2 minutes of a CPU renderer. I set the values for this render, so it takes about 2 minutes to resolve the noise and everything for this. And I wanted to see, well, at the same time on the same instance that it takes the CPU to render, how long is it going to take to render, the GPU side? And it's basically, it's watching paint dry, but as the CPU is resolving, the same GPU instance can do 5 images over the course of 1 image. So when you're looking at like a massive speed up in performance, this is it. Now, part of this is not just rendering. You're also looking at on per frame basis, you're loading the image data and then you're clearing up buffers and you're writing the image to disk. Now, writing an image to disk might not take long. It might take a couple seconds, but when your render is only 20 seconds long, and you've added 4 seconds or 5 seconds onto it, with all that's gone, we could probably go 6 or 7 images. So the actual, rasterization, or not rasterization, the actual ray tracing and shading portion is much faster. But we can also use this for, what can we do in a viewport? So this is basically just showing Maya in a viewport. Well, most lighters and look dev artists would be looking at a proxy of what they're seeing, and they'd have a window off to the side where they would hit a button and they would, say render, and they would wait for a few minutes. This is actually a full path tracing viewport. So this is Arnold in the viewport, fully selectable. You can tumble around, you can look at it, and it's going to resolve the image right there. So when you're looking at, making decisions of, I actually want the reflection here, or I want to see a specular highlight there, you can see it, nearly in real time. And so the final section I want to go over is talking about AI, so CUDA-X. Basically, we have a whole bunch of software libraries out there that accelerate machine learning and data science, and a lot of those are geared towards what we do with visual effects and animation. We talked about one of them, denoising. So we have this thing that's called a recurrent autoencoder. But essentially, one part of optics is the whole ray tracing framework, and another part of optics, we have a separate API for denoising. You can pass it a noisy image, and because it's been trained on tens of thousands of images, basically the noisy version and the clean version, it kind of knows how to interpret, what that final image would be. So when you're looking at it, this is an example, from Pixar, essentially of looking at a noisy version of a render and the equivalent literally just turning on optics, which takes a few milliseconds to calculate. So essentially, it's a real-time denoiser in your viewer. So as you're working, you can work in a space where you can more accurately judge the quality of the shading, the quality of the shadows, and you can get a better sense of the depth within the environment. And this is essentially akin to about a 10x speed up in your workflow without changing anything about your hardware. The other thing we talk about a lot is super resolution. There are use cases where you're a compositor and you've been given plates, and the director wants you to punch in 50% into a plate. Well, good luck. After 10%, everything's going to start to break down. So you use regular upscaling techniques, and so you might use a bilinear upscale, in Photoshop. But you can take a look at specifically like around the headlight and the light cover. You can kind of see the jaggies that are kind of there. And then so I'll calculate a little better, and I'll use a bicubic. And it's a little better, but this doesn't look like a high resolution image. But through deep learning, essentially, we've trained a network to learn features of the image. So it doesn't look at pixels, it looks at curves and shapes, and it interpolates those. So if you look at that, the text on that light cover, it's crystal clear. It had never seen this image before, but we passed it through it because it knows those types of shapes. It's looking to reproduce that same type of a workload. And another thing we do a lot of is style transfer. And you may have seen there's actually some demos out there where they're showing style transfer where you can take a photograph and convert it into a Picasso-style image or a Monet or something like that. But you can also do more with that. And so we introduced a thing we called fast photo style, where essentially we're taking multiple images and we're using one as a content image. So this is great, but what would this look like with this type of a coloration? And we can basically pass them both into the network and get an end result. And where this can be really useful is if you're working on a show where you know what your environment is. The director has chosen this as the environment, but I need to see this environment in the wintertime. We're not shooting in the wintertime, but we might have some matte paintings that are going to be done in the wintertime. How can we visualize that? So we can pass these to the network, and we can essentially see what a wintertime version of that is. And you can essentially use this as a starting point for, this might not have all of the the detail and the nuances that the director wants, but as far as like getting you in that right direction faster so that you can then say, okay, the director likes this, and now you can put your map painters to work without wasting their time. And another thing that we accelerate is locomotion. This is kind of something that I did years and years of animation. And so there's a lot of time that's spent on making characters move and making characters move intelligently. And if we look through the parts of the pipeline, there's parts where it's like pre-visualization and then there's final animation. And a lot of times in pre-visualization, it looks like someone's like got a Muppet and just kind of moving them around because they're trying to do it quickly. But what if you can move a character around a scene like you can in a video game? I can literally just drive a character around a scene. I want them, but I don't want them to, I'm not building a video game. I don't have 50, artists in 2 years to do it, but I build out an environment and I want my character to be able to walk around it. So there was a network created, in the University of Edinburgh called the Face Function Neural Network, and basically breaking it down is, this is a character that learned from motion capture data, and we just evaluate, this person at every frame, it knows, well, what is the ground like underneath me, what is my trajectory, and what is my speed, and what is my current position. So on every frame, it knows what its next potential frame is going to be based on those inputs that you're giving it. So you can drive a character around. So now when you're doing previs on something, you can have something that actually works through the environment as opposed to just, like, oh, I'm moving my character around. So, and how does this work? This works through like tons of data. So with this example, essentially we have motion capture data. So we've got a ton of motion capture data on top of a 3D skeleton, and we have to capture every action that we want to do. The network doesn't know something that it hasn't been trained with. So essentially, if you want it to walk, uphill or downhill or climb a ladder, you basically capture that motion, you throw it in there, and based on the inputs, it should be able to figure that out. So, and that's what we kind of did. We created, all of these things in order to create, that demo was created by the University of Edinburgh, but we've got some demos out there on the web that you can find out where we could show like 500 characters walking around a scene in real time on one GPU. So creating crowds at like more of a massive scale that actually are intuitive with the environment. And this is a video of basically the work that they did after that, where we tried adding a face function neural network onto a quadruped, and it didn't work as well. The motion of the feet, because at different rates, they have very different gaits. So they basically came up with a whole new network that works really well for quadrupeds. And this is the same thing. You basically have a wolf or a dog that can walk around an entire environment. So if you are prevising, name your dog movie that comes out every 2 years, you could use something like this, and you can actually, show the director, camera positions of what's going on. You can see the dog within the environment. You can drive it around, and you can iterate. So with all of these things, like, we're bringing AI to the process because we want to be able to help animators iterate or artists iterate on things faster, because the more you can iterate, the faster you can iterate, the better your feedback and the better the final results. So that's what I've got.
Awesome. Good. Cool. All right. Can you guys hear me okay? Okay, excellent. So thank you guys very much for coming to the presentation. Hopefully, after watching this, you're thinking more about how you can take advantage of the cloud for your own studios, whether you're already bursting the cloud a little bit or you're thinking about just going there completely 100%. If you have any questions, we're available for about 15 minutes, I believe, afterwards, so just feel free to come on up. We can have a deep conversation about what you're currently trying to do, and if you are definitely interested about diving in, you can either contact our BD team, who would love to help you out, help you figure out how to integrate this into your studio, or you can also contact Rick directly right there. Thank you very much, and enjoy the rest of your reInvent.